Hello, this is Mr. Passon. Welcome back to Math 7. Today we are starting a new unit on surface area. So this is Unit 8, Lesson 1, Intro to Nets. So a surface area is the area on the outside of a 3D object. We are going to be drawing objects and trying to make them look 3D on the flat paper. So we're going to think that this looks sort of like a pyramid like you would see in Egypt. And you can imagine it being out there, and you can count the different sides. Just like this one, well, looks like a block, like a cement block, and you could count the sides. And one of the things we're going to ask is how much area is on the outside? What is the surface area? Or like how many squares would it take to cover? Because we're always talking about in area, how many squares it takes to cover. So we're not filling it up, but we're putting like little squares on the outside. Now, when we do that, we're going to look at these shapes, and we're going to talk about different things. Now, with things with flat sides, we're going to call those a face. All right? So, we're going to talk about what a net is in just a bit, but we're going to start with these parts here. So, faces of a three-dimensional figure are any of the surfaces, including the bases. All right? So, this one has the base on the bottom, and then 1, 2, 3, 4 sides, the two in front and the two in back. This one's got a face on the bottom, on the left, on the right, on the front, on the back, and on the top. So this one has got 6 faces. All right, now a base of a three-dimensional figure names the shape. All right, a prism has 2 bases which are parallel to each other and do not touch. So this one here is a prism. The top and bottom are parallel, they do not touch. Okay, this one is not a prism. There are no 2 faces that are parallel. Right? A vertex is the corner of a three-dimensional figure. So let's look at this one. This has got a corner here, 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 and here. There are 5 corners, whereas this one, there are 1, 2, 3, 4, 5, 6, 7, 8 corners. Those are each the vertices, and vertex is singular, vertices is plural. All right? Then we have an edge. The edge is the line segment that joins 2 faces. So this right here is an edge between these 2 faces. This right here is an edge between the left face and the back face. Maybe the front face. It's hard to tell which one is the front. This bottom face and this edge here connect these 2 faces. So this edge, we've got the edges of the line segments. All right? Now, so what we're going to do is we're going to think of these three-dimensional shapes and think of their outsides and what makes them up. So this one is, it's got 1, 2, 3, 4 triangles, and 1 either square or rectangle. I'm not sure if the bottom is a square or a rectangle. This one is made up of rectangles and maybe a square. I'm not sure if this is a square or a rectangle. Alright? So now we finally get to talk about what a net is. A net is a 2-dimensional composite figure. Okay? So just like before, when we took shapes and we put them together, here we have some examples of some nets down here. But these nets you can fold up, and when you fold them up, they will make this cube. Alright, well at least some of them will. We'll figure out which ones. So most of the time we're going to look at a net as sort of an object and a way to sort of unfold it if it were hollow and see what all the faces are. Alright? Now, when folded, a net creates a 3-dimensional object. Okay. So this one, if I fold up these two sides and then wrap this around and fold this up, I would get this cube. This one, I get the same thing. This one, if I wrap these four around, and I can fold this one on one side and this one on the other. So all of these three can make the cube. All right, what about this one here? Is there a way to fold it up so that it makes the cube? And yes, it does. All right, so we might have to visualize that one. So this edge goes to this edge, and this edge goes to this edge. And that would mean that this is sort of folded. This becomes, say this is the bottom, then this is the back, this is the left side, this is the right side, this is the top, and this is the front. Alright. However, this one here, number 5, cannot create the cube. Think about how you would try to fold it up and what's going to happen, why this one doesn't create the cube. Let's actually use proper Roman numerals, probably make them capitalized. So nets 1 through 4. And remember, Roman numerals, I is 1, 2 I's is 2, 3, this is 4 because it's 1 less than 5, and this is 5. Alright, so when we're talking about the area of a surface, we're often going to decompose it into a net and then add up the area of each one of the pieces. We also want to just be able to visualize what nets fold up into what three-dimensional shapes. Alright, so let's go ahead and go on to page 2. Now, what does the net for this look like? Well, it's got a square on bottom. So I'm going to just draw a little quick square. Oh, move this one down a bit. Oh, well, this is hard to do. All right, let's try this a different way. I'm going to use this tool because it's a little bit faster for creating things. And then we have a triangle on each one of the sides here. And again, not doing a great job here. But if this triangle were the same as that triangle, all these would fold up and we would get this shape here. If we look at this one here where we could fold, let's look at the bottom. And on the left and on the right, there are those little squares. Right? Get one like that. Come on. Did not like that. Let's undo that. We'll try just one more time to get that right. And one over here for the left or for the right side. And then, oh, well, if that's the bottom, there's the back. Undo. Oh. Should be the same size. And then we can do the top. And the top should be the same as the bottom. And then the front should be the same as the back. So this would be one way to do it. This one we see there are 3 rectangles. Ooh, I'm going to just make one big one and then cut it into little pieces. Sneaky! So I can cut that. I can think of these as 3 pieces that wrap up, and then there's a triangle on each end, right? Something that looks like that. And if we fold up everything, we get that shape there. Alright, now, unfortunately, I'm going to lose all these when I move it on, so if you need to copy it down, pause the video. But I'm going to have to erase all that. Alright, how is the net of the pyramid different than that of the prism? Let me go back to this tool, pen tool. Well, let's think about it. The pyramid is different from the prism in that the pyramid has triangular faces and only one base, but the prism has two bases, the top and the bottom, and rectangular faces. So, pyramid has one base, and the sides are triangles, whereas the prism has two bases, and the sides are rectangles. Okay, so we could think of this as the top or this is the base, and this is the base, and then there's the four sides. Here is a base, and here's a base, and then these are the three sides. So this is a triangular prism, and this is a rectangular prism, or a square prism. If that's a square, that's a square prism. So remember, they're named by the base. This is either a square or rectangular pyramid because the base is either a square or a rectangle. Now, we can use the measurements, and the idea is we can label the different sides. So first, this one is the one that folds up to this cube. So each side is 7. Right? This one, which one folds up into this shape here? Well, it is this triangular prism. So there's 3 rectangle sides and 2 triangles. So every side is 5, and then the long sides are 15. So let's put a 15 up here, a 5 here, a 5 here, and a 5 here. And if we want, we can also write like 15 on this side. This one is our square pyramid. The base is a square, so it's actually this one over here. So this side here is 7 and 7, but the bottoms are 6 and 6. And then the height is actually only 5. So if we had to draw on the height, we would get the 5. This one, ooh, it's got all sorts of fancy sides. So it's got the short side, which is 2 feet, a longer side, which is 6 feet, and the longest side is 10 feet. So it looks like this long side is our 10 feet. This side looks like our short side, so I'm going to call that 2. And this side is our 6. Okay. Now this one doesn't look like it folds up exactly. I mean, these are the ones that I think sort of are the hardest stretch. This one's got a triangle on bottom, and this is the only one that's got a triangle on bottom, so it looks like we've got a 9, a 9, and a 9. So all the sides are 9 on the bottom there. And then along this side, I don't know how long this side is, but the height here, this part right here, from the middle to the top, is the 12. Alright, so again, not sure how long this side is, but we know from the middle up to the top is 12. Okay, summarize what you learned, and that is our introduction to nets.